Alright, so in the previous video, we have looked on how we determine the equation of motion in matrix form. So I forgot to mention that sometimes the question asks us to determine the equation of motion in matrix form with all known values. So if the question asks you to put in all the known values, so what you need to do is that we need to replace all the known values of mass 1, mass 2, K1 plus K2, negative K2, negative K2, K2 plus K3. So how do we get all those values is from the question. So the question already gives us what is the values of those. So mass 1 is mass 1 is 10, mass 2 is 1, K1 plus K2 is 35, negative K2 is negative 5, negative K2 is negative 5, and K2 plus K3 is 5 plus 0 is 5. So this is the equation of motion in matrix form, complete with all known values. And if you want to check whether your equation of motion is correct or not, so make sure these and these are the same. So if let's say in here maybe you got negative 4 and this one is 5, so something wrong somewhere because it is not the same. So please check back your free body diagram. Or maybe in here you got positive 5 and this one is negative 5. Again, it is not the same. So there must be something wrong somewhere with your arrow or direction. Okay, so please check back. Alright, now we're going to continue with natural frequencies. So since this problem are 2 degree of freedom system, so what we will get two natural frequencies, which is omega n1 and also omega n2. Okay, in which you need to remember that omega n1 must be smaller than omega n2. So later on you will use your calculator to obtain this value. So if you got two values, remember that the smaller value is omega n1 and the larger value is omega n2. So how do we find the natural frequencies? Alright, first we need to assume harmonic motion. So harmonic motion is given by x equals to a sine omega t, and x double dot is the second order differentiation, which is negative omega squared a sine omega t. So once we got this harmonic motion, so what we need to do next is that we need to replace this assumption of harmonic motion in the matrix. So what do I mean by replace? So this equation x equals to a sine omega t, we will replace in the x matrix here, and x double dot will be replaced in here. So if I replace it in there, so I will get 10, 0, 0, 1, and then x double dot, it will become negative omega squared a1. Why it is a1? Because here is x double dot 1, so a1 sine omega t, and x double dot 2 will become negative omega squared A2 sine omega t. Okay, so we're done with first one. Next, we'll move to the second one. 35, negative 5, negative 5, 5. Same again, replace this in here. So x1 will become A1 sine omega t, and this one will become A2 sine omega t. And this is equals to 0. So if you look in here, there are similarities, so we can simplify it by cutting off this one. Okay, so end up we will get the equation in terms of A1 and A2 here. So basically what we want to do is that we want to find the determinant. So what we need to do is we try to simplify the equation to become A1 and A2 is equals to 0. So we will move this one to the left hand side, and in the end we can simplify the equations to be like this. So if I move this to the left hand side, okay, so it will become negative 10 omega squared, and then the second one will become 0 because 0 multiplied with negative omega squared is 0. So 0 and negative omega squared. So this will become A1 and A2 plus okay, since this one we don't need to change anything, so it will remain 35, negative 5, negative 5, 5, A1 and A2, and this is equals to 0. So remember that I said we want to simplify things to become like this. So we can combine these two together. So if I combine these two together, it becomes 35 minus 10 omega squared. Okay, and negative 5 plus 0 is negative 5. Negative 5 plus 0 is negative 5. And 5 plus negative omega squared will become 5 minus omega squared. Okay, and then it will become A1, A2, this is equals to 0. So next, what we need to do is that we need to apply Cramer's rule. Okay, we need to apply Cramer's rule. Why do we need to use Cramer's rule? Because we want to find the determinant of this omega. So how does Cramer's rule work is that if I have A11, A12, A21 and A22 equals to 0, so Cramer's rule states that A11, this multiplied by this, so A11 multiplied with A22 minus this multiplied by this, so A21 minus A12 is equals to 0. So what is our A11? So this is our A11, A12, A12, A21 and A22. Right, so we will use Cramer's rule. So you'll get 35 minus 10 omega squared multiply with 5 minus omega squared minus negative 5 multiplied with negative 5 equals to 0. Okay, so next what we need to do is that we need to expand this. So 35 times 5 5 minus 35 omega squared minus 50 omega squared plus 10 omega to the power of 4. Okay, so what we do is we expand this. Okay, minus negative 5 is 25 positive equals to 0. So next is we simplify this equation. So remember to write the highest order first. So 10 omega to the power of 4. Okay, what I normally did is once I wrote it down here, I'll just cut this off so that I remember that I already done it. So next higher order is omega squared. So negative 50 minus 35 omega squared is negative 85 omega squared. So again, slash it. And then last one is 175 minus 25 is 150. So it will be positive 150. And this is equals to 0. So normally a careless mistake that student always did was the sign here. Sometimes they write negative and positive. So please be careful. Okay, look carefully. Alright, and then remember that what we want to identify is this omega value. So how do we determine the omega value? So substitute, let's say x equals to omega squared. So this equation will become 10x to the power of 2 minus 85x plus 150 equals to 0. So using our calculator, okay, please don't use negative b plus minus b squared minus 4ac because we already have our calculator. So we put in all our calculators. So mod equation 2. So a is 10, b is negative 85, c is 150. So by using my calculator, so I get two value of x, where in my calculator it write x1 is equals to 6 and x2 is equals to 2.5. So x1 equals to 6 and x2 equals to 2.5. So we know that x equals to omega squared. Okay, so omega 1 squared is actually 6 and omega 2 squared is 2.5. So omega 1 is square root of 6 and omega 2 is square root of 2.5, which is 1.58. Okay. But this is not true because, as I mentioned earlier, that omega 1 must be smaller than omega 2. So what you should do is that you replace this one, because we know that omega 1 squared must be smaller than omega 2 squared. So this should be 2.5 and this should be 6. Why? Because remember, omega 1 must be smaller than omega 2. So this one is 1.5811 and this one is 2.449. Okay, the unit is radian per second and this is radian per second. So this is the final answer for natural frequencies.